Hi, my name is Meeta Kumar. In this module, I will discuss concepts relating to production in some detail. In particular, we will discuss the law of variable proportions or returns to factor, the various stages of variable proportions, and the reasons for this. We will also examine the law of returns to scale, the stages of returns to scale, and the underlying reasons for this. These are important to understand because these determine the shape of the total product curve, the average product curve, and the marginal product curve that we have already studied in a previous module. Let us start with returns to factor. This means change in total physical product when an addition or incremental unit of a variable factor is employed, given all the fixed factors. Alternatively, when only one variable input is increased, keeping other inputs constant, the resultant increase in output is called a return to a factor. As the amount of the variable factor is increased, returns to factor change according to the law of variable returns to factor, which is also called the law of variable proportions. According to this law, if more and more units of a variable factor are employed with fixed factors, the total physical product, which is TPP, initially increases at an increasing rate, and then after the point of inflection, it increases at a diminishing rate. Eventually, it starts falling. With reference to the marginal physical product, the law states if the amounts of a certain variable factor are increased, keeping the amount of the other factors fixed, the marginal physical product first increases and then falls and then eventually becomes negative. Since the proportion in which variable factors and the fixed factors are combined change, therefore, this law is called the law of variable proportions. Thus, when more and more of a unit of variable factor are combined along with fixed factors, the total physical product passes through three phases. First, it increases at an increasing rate. Next, it increases at a diminishing rate. And then eventually, it starts declining. Similarly, in terms of the behavior of the marginal physical product, the marginal physical product rises in the first phase, reaches its maximum, and then falls in the second phase, and in the third phase it becomes negative. This law operates in the short run when all factors of production cannot be increased or decreased simultaneously. Let us now list the assumptions of the law of variable proportions. First, it operates in the short run where factors are categorized as fixed and variable factors. Under this law, the different variable factors are combined with fixed factors. The technology given remains unchanged. If technology improves, then the marginal product and average product may increase instead of falling, and the law of variable proportions will not apply. At least one input must be kept fixed. For example, capital is fixed. This law does not apply if all factors are variable. We also assume that factors which are being used in production are imperfect substitutes for each other. Let us discuss the law of variable proportions with the help of the following schedule and diagram. Consider a field which is being cultivated for growing wheat. The field has an area of 1 acre. The schedule on your screen describes how the TPP and MPP change as more and more labor is hired to cultivate the field. This data can be represented in the diagrammatic form as shown in Figure 1. On the basis of changes in TPP and MPP, the law of variable proportion classifies into 3 stages the TPP. We can use Figure 1 to understand these phases. The first stage refers to the law of increasing returns to a factor. When the units of variable input are increased, keeping the fixed factor constant, then fixed inputs are utilized in a better way and in a more efficient manner. As a result, efficiency in the production process increases. TPP starts increasing and it increases at an increasing rate. This stage continues till the level where the fixed inputs are utilized to their utmost efficiency. That is, the level where the marginal physical product becomes maximum. In the diagram on the screen, you can see that this will happen till the second unit of variable factor is employed. TPP increases at an increasing rate until this point. The slope of the TPP is becoming steeper. At the point P in the lower panel, the producer is able to generate maximum additional production, that is, the MPP is maximum at 20 units, resulting in a total production of 30 units represented by the point Q on the top panel of the diagram. The TPP curve is set to display increasing returns to factor till the point P or till the use of the second unit of the variable factor. After point P, the marginal product falls and TPP increases, but it increases at a decreasing rate. Q is therefore called a point of inflection. This level of production is termed at the point of inflection because TPP changes from increasing at an increasing rate to increasing at a decreasing rate. Let us look at the reasons for the first stage, that is, for increasing returns. The most fundamental reason for increasing returns to factor is a better utilization of fixed inputs. When inputs of the variable factor are increased, keeping the other factors constant, then fixed inputs can be used in a better manner and in a more efficient manner, due to which the productivity in the process starts to increase. For example, in the field which we have shown in the schedule above, 2 men are clearly more efficient than 1 man working alone. A second reason for increasing returns to factor is the indivisibility of inputs. So, the indivisibility of inputs can be explained with the help of an example. A teacher is fully competent to teach a class of 30 students with ease and efficiency. If the number of students falls to 15, you can't have the teacher and you cannot have the efforts of the teacher. So, the teacher has to put in the same effort, but his output has been halved. When units of a variable input are increased, then the indivisible inputs can be utilized more efficiently, due to which efficiency in the production process increases. Increasing returns to factor also arise because of division of work, often called the division of labor. When units of variable input are increased, then the principle of division of labor can be applied in the production process. This leads to an increase in specialization and hence efficiency in the production process. We can now turn to the second stage, or the law of diminishing returns to a factor. The law of diminishing returns to a factor states that if we keep increasing the employment of an input with other inputs fixed, eventually a point will be reached after which the resulting additional output, which is the marginal product of that input, will start falling. When the units of variable input are further increased, variable inputs have less and less fixed input to work with, and the factor proportions between the fixed and the variable inputs become suboptimal, due to which efficiency of the production process starts falling. The total physical product continues to increase because the variable input is being increased, but it increases at a diminishing rate. This stage continues till the level where the marginal physical product becomes 0 and the total physical product reaches its maximum value. As shown in the diagram and the table, after the second unit of variable factor has been used, if more variable factor is employed, then the marginal product starts to fall. It touches the x-axis at the fifth unit. At this point, S, the marginal product actually becomes 0. Notice that the total product has reached its maximum of 52 units at the corresponding point M. What are the reasons for the second stage of the law of diminishing returns? Basically, if the unit of variable inputs are increased, to utilize the fixed inputs beyond their maximum or beyond the optimum, then the factor proportions between the fixed and variable inputs get disturbed, due to which the efficiency in the production process starts falling. In our example, too many workers on the same field may actually obstruct each other while working, causing the output to grow more slowly. A second reason for diminishing returns to factor is often imperfect substitution. Variable inputs can be substituted for the fixed input only to a certain limit. If the units of variable input are increased beyond that, then due to this imperfect substitution, the efficiency in the production process will fall. Moreover, substitutes for every fixed input may not be available, due to which also the efficiency of the process falls. In our example, labor cannot substitute for land beyond a point. The third stage of the law of variable proportions, or the law of negative returns to a factor, operates when the units of variable input are used to an extent when the marginal physical product becomes negative and the total physical product starts falling. In our diagram, this happens after the employment of the fifth unit of the variable factor. You can see that after the fifth unit, the marginal product has gone negative and the total product has started to fall. What are the reasons for the third stage? The most basic reason is the poor coordination between variable and fixed factors. When variable factor become excessive in relation to the fixed factor, then they obstruct each other. Too many workers on the same field in our example will only get in each other's way. As a result, total output falls instead of rising and marginal product becomes negative. A second reason could be the decrease in the efficiency of the variable factor. With continuous increase in the variable factor, the advantages of specialization and of division of labor start diminishing. This results in inefficiency of the variable factor, and this can cause returns to factor to turn negative. We have so far looked at production in the short run. We now turn to production in the long run and examine the law of returns to scale. The law of returns to scale operates during the long run and represents the effect of changes in scale of production on the output produced. The scale or capacity of production is said to be changed when all inputs in the production process are increased in equal proportion, keeping their ratio constant. When the scale of production is increased in order to increase the output, then the output increases either at an increasing rate or a constant rate or at a diminishing rate. These three possibilities are termed as increasing returns to scale, constant returns to scale, and diminishing returns to scale, respectively. When the total production increases more than proportionately as compared to the increase in inputs, then it is termed as increasing returns to scale. For example, if inputs are increased by 100% and the total product increases by 200%, then it would be termed increasing returns to scale. Increasing returns to scale represent increase in efficiency in the production process due to better division of work and the use of specialized machines. Increasing returns to scale can be explained with the help of the schedule on your screens as Table 2. Here, when labor is doubled from 2 units to 4 units, and capital is simultaneously doubled from 1 unit to 2 units, notice that output increases from 10 to 25 units. You can see that a 100% increase in both inputs has caused a 150% increase in output. Output has increased more than inputs in proportionate terms. Can you work out the proportionate changes in inputs and output between the second and third rows of the table? What proportion have inputs increased by? And what proportion has output increased by? Does this display increasing returns to scale? As you've probably worked out, inputs have increased by 50% and output has increased by 60%. So, increasing returns to scale do hold. When the total production increases in equal proportion as compared to the increase in inputs, then it is termed as constant returns to scale. For example, if inputs are increased by 100% and TPP also increases by 100%, then it would represent constant returns to scale. Constant returns to scale can be understood with the help of the schedule on your screen. Here, when labor is doubled from 2 units to 4 units and capital is simultaneously doubled from 1 unit to 2 units, output increases from 10 to 20 units. You can see that a 100% increase in both inputs has caused exactly a 100% increase in output. Output has increased exactly as much as inputs have in proportionate terms. Can you work out the proportionate changes in inputs and outputs between the second and the third rows of this table? What proportion have inputs increased by? And what proportion has output increased by? As you've probably worked out again, inputs as well as output have both increased by 50%. So, constant returns to scale hold in this case. We use the similar logic to explain decreasing returns to scale. when the total production increases in a smaller proportion as compared to the increase in inputs, then it is termed as diminishing or decreasing returns to scale. For example, if inputs are increased by 100% and the total product increases by only 80%, this would represent diminishing returns to scale. Once again, let us look at table 4 to understand this. Here, when labor is doubled from 2 units to 4 units and capital is simultaneously doubled from 1 to 2 units, output increases from 10 units to 18 units. You can see that a 100% increase in both inputs has brought about an 80% increase in output. Output has increased, but it has increased less than inputs in proportionate terms. What about the proportionate changes in inputs and outputs between the second and the third row of the table? What proportion have inputs increased by, and what proportion have output increased by? As you've probably worked out again, inputs have increased by 50% and output has increased only by 38.88%. So, we have an example of decreasing returns to scale. What are the reasons for increasing returns to scale? Increasing returns to scale generally occur due to economies of scale. This refers to benefits attained due to large-scale production. Economies of scale can be classified into two categories: internal economies. These refer to benefits of large-scale production which are available to a firm within its own production process. For example, technical economies in the form of the use of bigger and better machinery, and managerial economies through division of labor and specialization would contribute to internal economies. External economies refer to benefits of large-scale production which are shared by all the firms in an industry when industry as a whole expands. For example, if there is better infrastructural facilities or the discovery of a cheaper source of raw materials, this causes external economies of scale. Decreasing returns to scale generally occur due to diseconomies of scale. Once again, diseconomies of scale mean that a firm has grown so large that it becomes very difficult to manage it. Diseconomies of scale can also be of two types. These can be internal diseconomies, and this refers to disadvantages of large-scale production which a firm has to suffer due to its own production process. For example, the difficulty in coordination and management of very large firms. Technological diseconomies can also arise because of heavy costs of wear and tear. External diseconomies arise when the disadvantage of large-scale production is suffered by all firms in an industry. And this usually happens when the whole industry expands. For example, there might be a shortage of a certain crucial factor, or there might be congestion causing transport delays and therefore higher costs. For all these reasons, costs in the industry would go up. To conclude, we emphasize the difference between the returns to a factor and returns to a scale in this module. Returns to a factor operate during the short run and represent the effect of changes in the unit of one variable input on the output, keeping other factors constant. Whereas returns to scale operate during the long run. They represent the effect of changes in scale of production of an output produced. To recap, what we have done in this module is that we have looked at the law of variable proportions that operates in the short run and at the law of returns to scale that operate in the long run. We have also tried to understand the reasons underlying these laws. We will use this basic understanding of the way total product changes when inputs are changed to try and understand how firms make their production decisions in the modules that follow. Thank you.